Good morning, students. Today we are going to discuss about the topics on transistors. What are transistors? What are their applications and how they are going to use it? How we are going to use it. So yesterday we have discussed about the formation of PN junction, PN diode, their application, how they can be used as rectifier, and now what are basically transistor? Transistor basically made up of two parts, trans plus resistor. Transistor, it is not a radio, it is a transistor, means it is a device where the transfer of resistor takes place. Transfer of resistance means it is a special kind of device which is made up of again p and n type semiconductors. So but the special configuration is different. It is either made up of two n-type semiconductors sandwiched with the p-type, NPN, or it is made up of two p-type semiconductors sandwiched with N. So either it is form of PNP or NPN transistor. So basically it is a three-leg device, unlike a two-leg device as of a diode. So this is a practical kind of diodes, three legs, which is made up of emitter, base, and collector. This is called as emitter, and this is base, and this one is collector. So emitter, base, and collector, these are the three different parts. Same is here, emitter, this is the base, and third is a collector. Now, but their configuration is not symmetrically with respect to each other. Now, not symmetrically means there is some difference in the width of the transistors. For example, the width of the emitter is medium. This width is medium, while width of the base is very small, while the collector width is very large. And then what we are going to do, the doping, the impurities which are being done is heavily doped. Emitter is heavily doped. It is the lowest doping, and here it is a medium doping is done. And then it is being the biasing is being done, that we will discuss later on. Now, so that means the exact structure of NPN transistor is like this way. It is a medium size, it is a smaller size, but it is a larger size. So it is not a symmetrical transistors NPN. As you already know, the N-type semiconductor consists of majority carrier as electrons and minority carrier as holes. P-type has majority carrier as holes and minority carrier as electrons. Again, this is a N-type. So it is two P and N-type semiconductors are being joined back to back. Is it possible that we make two diodes attached to each other and make a transistors? No, it is not possible to make such kind of things. So we have to substitute or make the transistors in a particular way, that is p type, n type, and then this is slightly wider, again it is a p type. So n type has to be sandwiched in between it, so it should not be connected externally. So basically the base transistors, base of the part, help in supporting the flow of electrons from one part to another part. So basically now we will discuss about the all the different parts of the transistors. Now first is the emitter region, which either it is of PNP type or NPN type. So we are talking about the PNP transistors. So this is the emitter part, which is majority carrier as holes as majority carriers, and minority carrier as electrons. Electrons as minority carrier. And in the N type, so it is a base which has majority carrier as electrons and minority as holes. So this is heavily doped because it has to extract maximum flow of current. So maximum flow of current has to flow from here, so that means it has low resistance, while the other part of the NP will have the high resistance. So that means the resistance is changed from low to high. So that is transfer of resistance is bring from high to low. So that's why it is called as a transistor. So transistor has been name given because the resistance has been changed from low to high. Now, then the second part is base. Base is a lightly doped region, and it is and the width of the base is approximately around 10 raised to minus 2 centimeter, and this help in sporting the current from one to another one, and which help the transistor to maintain the current from one side to the another one. And then the third part is collector, which is medium doped, but it is larger in size, and it is always a reverse biased. So third part of the that is the current which is emitting from the emitter, and after passing through the collector it get emitted out from the get collected at the collector end. So that means when you explain the working, so working will be slightly different. So in working we are going to make one part as a forward bias, another part as a reverse bias, so that the proper working should takes place. So in that case, so let us say P and P. So in case of this, so P type is connected to P positive and N type is connected to negative, so it is forward bias, and then it is connected to this one, and then this is to the reverse bias. So that means forward bias part is there and the reverse bias part is there. So forward bias part, the emitter current will be flowed from this to this one, although it is very weak region, so very sporting region, and only very small part of current will be taken by it, and rest of the current will flow through this one. So once the rest of the current means only 5% of the current will be taken by the base, while the 95% will flow through it. So that means emitter current is equal to base current plus collector current. So it is divided up into two parts, emitter and the base current. Once the current is being collected by the collector, after getting through that, it will complete the circuit and the flow of currents will starts out. So that's how the PNP transistors work. Now, symmetrically, the NPN transistor can also work, but the diagrams will be different. In NPN transistors, so only the connections will be different. Let us say this is NPN. So here we will make it forward bias by making it the connection to be this one, and then this to be connected, and this will be connected as a reverse bias. So this part is a reverse bias, and other part is a forward biased. So that is how the biasing is done in the transistor. So that means the transistors can be explained, that is the two ways they can be used in lot of number of devices, like making ICs, and then other kind of things like gates, and many more things are going to be used for the particular applications. So they are also used in TVs, DVDs, VCDs, and many more home security systems, where they are very useful for us, although that is a separate part where we can able to use it out. Now the next part of that is how we can use it as an amplifier, as an oscillator. Transistor as an amplifier, and as an oscillator. Amplifier, fire, and as well as an oscillator. How we can able to use it out, that we will discuss up in the next video. Thank you.